The process of tumor formations and progression is influenced by two factors. First, genetic or epigenetic changes in the tumor cell. Second, rearrangements of the components of the tumor microenvironment through mutual and dynamic crosstalk. The microenvironment of a tumor is the set of cellular and molecular components that form the contact and which the tumor originates, grows, and eventually disperses through a normal tissue. These particular cells and molecules are in intimate contact with the tumor cells and participate in the two-way communications that ultimately support tumor progression. To understand more what is the tumor microenvironment, let's have a look on the analogy of a tumor as a house and the microenvironment as its yard and its neighborhood. The house is surrounded by a little ecosystem, and whatever happens in the yard or neighborhood will impact the house directly. Same goes to what happened in the house will directly impact the yard. What will happen if the yard doesn't drain after a rainstorm? It will cause the house to flood. In the case of cancer, when a tumor cells grow uncontrollably, it uses the microenvironment to grow faster and spread and making more tumors. Tumor microenvironment consists of, first, cellular component and non-cellular component. Cellular component consists of the tumor cells and tumor stromal cells, include stromal fibroblasts, endothelial cells, and immune cells like microglia, macrophage, and the lymphocyte. For a non-cellular component, which include the extracellular matrix such as collagens, fibronectins, hyaluronan, laminins, and others. In these presentations, we will focusing more on how the extracellular matrix alterations influence tumor progression. During cancer progression, tumor cells increase lactate productions, leading to an acidification of the tumor microenvironment. Tumor cell, cancer-associated fibroblasts, and polymorphonuclear leukocytes and monocytes will secrete proteases such as metalloproteinase that degrade extracellular matrix and release matrikine. CAF or cancer-associated fibroblasts will induce a higher secretion of ECM macromolecule that leads to an excessive deposition of ECM components. Tumor cells, PMN, and monocyte will produce ROS, which is a reactive oxygen species that degrade ECM component and particularly collagen 1 to facilitate the tumor cell migrations. Hypoxia also induce hypoxia-inducible factor HIF stabilizations, lysyl oxidase LOX, and transglutaminase activations, collagen and elastin cross-linking leading to ECM stiffening. This event will favor tumor cell migrations and cancer progression. As a conclusion, the tumor microenvironment is composed of various cell types embedded in an altered extracellular matrix. ECM not only serves as a support for tumor cells but also regulate cell-to-cell or cell-to-matrix crosstalk. By understanding on the ECM alterations occurring in the tumor microenvironment, provide new insights of potential use of the ECM fragment as a biomarker for cancer diagnosis and prognosis.